Hey there, welcome to this lesson. In this lesson, we're going to talk about another data structure that's part of the collections framework, and that's called a set. A set is basically very similar to a list, except that it prevents duplicates. When you have an array list or a linked list, you can put as many repeated data in there without worrying about, it's meant to store duplicates if needed. But a set data structure prevents duplicates from being inserted into it. So let's go over an example. Here I have the package lesson 3, and let me apologize for the incorrect, I would say, naming convention that I'm using here for the packages. This was sort of an afterthought. I thought that I'd have different lessons for different sections, and that's how I was structuring it. But this is the 27th lecture, so feel free to rename this package. Later on, we'll talk about the naming convention that you should be using and the naming convention that's used in the industry for package names. So when we get there, that will be more important. For now, let's just continue. I'm going to right-click and go to New, and let's create a class. And just like before, we're going to create a class called Application, and this is going to be our runnable class. We're just going to have the main method in there so we can just run it, the starting point of our application. So I'm going to define this set data structure. It's called a HashSet, and there are some other sets that we'll maybe look at later, but this is the most important that I want you to learn about. And the kind of data that's going to be inserted into this data structure is going to be of type integer. Okay, and let's just name it values. That's the name of the variable. And let's instantiate the HashSet integer. And there you go. To import the library, you just Control-Shift-O, and notice that it's coming from java.util HashSet. Okay, so we're still learning about the collections framework. This is a new data structure. Again, the set is used to prevent duplicates. Very similar to the list, except the list structure can have duplicates and repeats. You can't do that in the set data structure. So let's get started. I'm going to start adding values to this just like how we were doing before. Let's add the number 12, the number 43, 15, 67, and 43. Okay, so we have two 43s in here. I inserted it up here, and then down here I'm trying to insert it again. So this is the duplicate. So I don't want this 43 to be repeated in this set. So let's see if this works. Let's loop over it. The data type is integer, and I'll just call the variable value, and we're going to be looping over the values data structure. And let's just print the value variable. Now we have 5 numbers that are being inserted here, one of which are duplicates. Okay, so I only want to see 143 in this set of values that's going to be printed. All right, I don't want to see two 43s in there. So let's hit play and notice that we got 67, 43, 12, and 15. Notice that 43 is not being repeated. All right, if this was an array list, we could just very quickly just do this, array list, and let's change this to an array list. Everything else is the same. Let's just do the import. Notice that you're going to get repeats if you use the array list. Let's hit play and notice that we got 43 up here and 43 down here again. All right, but with the set, the hash set, we can prevent these duplicate values from being entered into the data structure. Another thing is the array list manages or maintains the order. All right, the order of insertion. 12 was inserted first, 43, 15, and so on. You could see that the same order is being printed. But with a hash set, let's change it back to hash set. Do the Control-Shift-O for the import. Hit play. Notice there's no order that's being managed here. It doesn't care about the order. All it cares about is unique values, and that's what we see down here. So similar to integers, we can have strings. Let me change this to the string data type. Okay, now the data that can go into values cannot be integers anymore. It could be strings. So let me just put some random words in here, starting with the word random. And let's add the word animal, people, random again, and random one more time. Okay, so we've got 3 randoms in here, 3 repeats. And we of course need to change the data type for the actual data that's in the values structure. And now let's hit play and notice that random is only being shown once. Okay, so this means that random was only inserted once on this first line. It inserted animal, it's inserted people, but then these 2 entries were ignored. Okay, it was not adding random again and again. So the set is very useful for unique values, and order is not managed here with the hash set. If you do want the order to be maintained, there's something called a LinkedHashSet. LinkedHashSet. And this does maintain the order. So let's do the Control-Shift-O, and we were able to import that library there. And now, for the sake of a better example, let me change this to another word such as zoo. And let's add another one here, car. Okay, so there's no duplicates, but I expect this to be shown in the order of insertion. So let's hit play and notice that it is in fact order of insertion because we used the linked hash set. But duplicates are still not allowed. Okay, let's try to put some more duplicates in there. Let's hit play and notice that there are no repeated cars and there's no repeat for people, but it's ordered in the sequence of insertion. So that's really the only difference between a linked hash set and a regular hash set. The linked hash set maintains the insertion order, whereas the hash set doesn't care about order. They're both used to maintain unique values. So let's go back to the hash set, and I want to go over another example. So we were entering integers and strings, but let's say we have our user-defined type. Let's say we have our own objects. For example, I'm going to create a class called animal, and I can use this structure to store animals. Let me show you how to do that. Let's right-click here and go to new. Let's create a new class, and we'll call it animal. Just hit finish. And for the sake of simplicity, I'm just going to put 2 fields in here. The first field is name of type string, and the other field is age. And then we'll get those default methods in here by doing right-click, go to source, and let's just get a constructor for these fields so that we can initialize these animals. And another thing that would be helpful is to use the toString method. So let's right-click here and go to source and go to toString so that we have a reader-friendly representation when we print an animal object. Okay, so now let's go back to the application class. Let me get rid of all of this extra stuff. We're going to rename this hash set to be something more meaningful, and we're going to be dealing with animals now, so I'm going to call the variable animals, and the kind of data that's going to go in here is of type animal. Okay, same goes for here. So this hash set is going to be maintaining animal instances. So let's instantiate a couple of animals. We'll call it animal1 is equal to new animal, and let's say the first one is the name is dog and the age is 12. I have these written elsewhere, so I'm just going to copy paste these values, and you can just follow along. If you need to pause the video, go right ahead. So we have 5 animals here, dog, cat, with the different ages. But here I have animal 4 is also a dog, and its age is also 12. So we have a repeat here. This one and this one. Animal 1 and animal 4 are repeated. So let's see if this hash set called animals, if that accepts our second dog. So let's go animals.add and add in the different animals. Animal 1, and I'll just paste this and change the values to animal 2, 3, 4, and 5. We're able to add in each one of those animals. And now, since the kind of data that we're looping over is an animal, we need to change this to animal. And the name of the collection is right here, animals. So let's do that. And now we'll just print out what is contained within this hash set. So let's hit play. And notice that we get the dog, And then we get the dog again. We get kangaroo, bird, cat. So notice that the hash set is not able to manage unique values. Even though we know this is a repeat. This is a dog with the age 12, and this is a dog with the age 12 as well. But in the hash set, it's not able to identify whether these are repeats. In the previous course, Getting Started with Java, I showed you the equals method. So let's see if we can check for equality between animal 1 and animal 4. So we could do animal 1 dot equals animal 4. And let's just do a sysout of that value. So this is going to return either a true or a false. If animal 1 is equal to animal 4, it's going to return a true. Now we know that the values for animal 1 are exactly the same as the values for animal 4. But let's see if this equals method works. I'm going to comment out this loop here, and let's hit play. And lo and behold, it's false. In other words, it's not able to consider both of these values as equal. So remember, in the previous course, I told you that you have to override the default equals method. So the way we could do that is just go back to the animals class, right click and go to source and go to this generate hashcode and equals. I'll click on that and hit OK. And this is the equals method. So it's actually comparing the different values of the fields with the object that's passed in. All right. So now we're doing a field to field comparison, the name equaling the name and the age equaling the age of the two different objects. So this is the correct way of doing comparison of two objects. And Eclipse basically has this shortcut that we can quickly implement this method without having to type it out. Now up here is a hashcode method, which we'll take a look at in just a second. I'm going to comment this out for now. And we just are left with the equals. So let's go back to application, and now let's see if both of these animals are considered the same. So let's hit play, and notice now it's showing true because it's doing a field to field comparison. But let's see if that helped. Let's see if our hash set is now able to recognize whether this dog and this dog, right, animal 1 and animal 4 are the same. Let's hit play, and notice that it inserted both of the dogs again. It's considering both of these animals, animal 1 and animal 4, as two different objects, and that's why they were able to make their way into the hash set. And again, what is the point of a hash set? The point of a hash set is to ensure unique values, but in our example here, it's failing to do that. It's allowing duplicates. The reason for this is the hash set goes by something called hashcode. If the hash codes of two objects are the same, only then it prevents duplicates. In our current situation, the hash code that belongs to animal 1 is different than the hash code that belongs to animal 4. Even though the values of the fields are the same, but the hash code is different. I'll prove it to you. Let's print out the values for these. So we could do sysout and do animal 1 dot hashcode. Okay, that's the hash code for animal 1. And let's print that out again for animal 4. So we do hashcode for animal 4 on this line, and notice that they're going to be different. So I'm going to just comment out this line for now. Let's hit play, and notice that the hashcode values are different. Okay, these are the values that the hash set uses to ensure uniqueness for user-defined objects. Now this is a user-defined object. We created a class called animal, and we created instances of that class. These are objects, user-defined objects. And this hash set is not able to figure out that both of these dogs are the same, even though we implemented the equals method. We also need to override the hashcode method. So let's go back to animal, and notice this hashcode method that I commented out. We need to uncomment that. And this is just a random number that's generated using the fields of this class. So now that I've uncommented out this hash code, let's go back to the application class, and let's check for whether animal 1 and animal 4 have the same hash code. Let's hit play, and boom, there you go. Notice that the values are the same. And now the hash set will be able to recognize that this dog with the age 12 and this dog with the age 12, animal 1 and 4, are in fact the same kind of data, same kind of object. Hence, it will prevent the duplicates. So going back down here, I'm going to comment out these for now. And let's show the loop again. And now it's going to show the unique values for animals. Let's hit play. And boom, there you go. You see the dog here, but we don't see it repeating again. And that is because the HashSet data structure uses the Hashcode method to ensure uniqueness. And if we do not override Hashcode, all objects use their parent object's Hashcode implementation, and that is belonging to, if we click on Hashcode and do Control T, notice it's coming from the object class. Click on object, and this is the general implementation that all objects will be inheriting from. So we need to override this method so that it's more specific to the fields of our instance, such as the name and the age. All right, so a lot of information there in this lesson. I would recommend you watch it a couple of times if you are confused. Don't worry, this is a tricky concept that takes some time for people to grasp, but once you see it enough, it'll make all sense. So a quick review: the hash set is used to ensure unique values. When you're inserting numbers or strings, it's very quickly able to prevent duplicates from being inserted. But when you have a user-defined object, such as in our case, we have the animal, we create instances of the animal, it's not able to differentiate between two objects even if they have the same field values, it's not able to identify the uniqueness there. Well, what we need to do is we need to override the equals as well as the Hashcode method in the class, in the animal class in this case. And once those are overridden, only then would the hash set be able to manage uniqueness for these user-defined objects. And to implement the equals and Hashcode is very simple. You just go to the actual class that you created, like we did here, and it's just a matter of doing right-click and go to source and generate the Hashcode and equals. Right? This is an Eclipse utility that makes things a lot easier. And what is this actually doing? Well, this is coming up with just some random number based on the fields that the values belong to the fields of a particular instance. All right, and if two instances have the same values, if they have the same name in this case, and if they have the same age, they're going to have the same hash code. And same thing goes for equals. It's using the actual fields, the data in those fields, to determine the equality of two instances of the same class, two objects. So hopefully that made sense. Play around with this hash set as well as the linked hash set. Remember, the linked hash set could be used if you want to maintain the order, and the hash set doesn't care for order. But both of these, the linked hash set as well as the hash set, their purpose is to ensure uniqueness of data, and they work almost the same way as any old list. Okay, so that pretty much wraps up this lesson. Thanks for watching. I'll see you in the next one.